30 seconds and counting. 25 seconds and counting. We are still go. 20 seconds. Guidance alert. The guidance system now going internal. 15, 14, 13, 12, 11, 10, 9, 8. Ignition sequence start. 5, 4, 3, 2, 1.
To all the alien enthusiasts in Europe and Africa, good afternoon. To all of you crazy folks in the Western Hemisphere, and good very early morning to everyone in the Pacific Rim, and welcome to the Angry Astronaut. So, yeah, odds are we have a huge crowd already. I have no idea how this is going to affect audio and video and all that sort of thing. You guys have already set a record, just to let you know. We have never, ever in the history of this channel had over 1,000 people waiting in the audience for things to get going here. So I am thrilled to have you here. Go ahead and let me know where you're watching from. I'm having a hard time probably keeping up with the chat, but hello, Hawaii and Philadelphia. Hello, and thank you very much. Hello, Mexico. We also have Roswell's. Where else? Germany. Hello, New Hampshire. I'm probably not going to be able to even read this. Hello, Indonesia. Thank you very much for watching today. Really, really appreciate it. Hello, Ontario and Oxfordshire. Thanks for tuning in. Oh, my God. Going like crazy. Chattanooga. Holy my God. It's just going too fast for me to even read it. Let's see. What do we have here? Thank you very much. Yeah, Bob, Airborne Bob just gave us a fantastic super chat. Thank you so much, Airborne. Hello, Netherlands and Canada, Philadelphia, Australia, Scotland. I'm just picking them out of the air. Hungary, and we have Romania. We have BC, Canada again. We have India. We have a lot. We have Italy. We have Belgium. Ethiopia, we have Los Angeles and Corpus Christi, we have Sao Paulo in Brazil, Southampton, hello, oh my God, hello, England and Hungary, and oh my dear Lord, Arkansas, Topeka, Kentucky. I'm just trying to pick these out. Liverpool, hello, hello, Ethiopia, boy, people watching Budapest, thanks so much for tuning in. Saturn, we have France and Amsterdam, Southampton, Quebec, crazy, Massachusetts, hello, hello, Azerbaijan, hello, Pittsburgh. Thank you so much. Really appreciate these super chat that just went zooming by. Angel Eyes, thank you so much, Angel Eyes. Boy, you guys are fantastic today. Really appreciate it. By the way, we just thank you. And just so you know, thank you so much. What? Guardian Bob, yeah, can't keep up. That's so you know, guys. If we hit our super chat goal, what is that tonight? Is it 5 or 10? Super chat goal. Thank you, J Squared. Thank you, Lenmart. Let's go ahead and set a 10. Let's set a 10 super chat goal here, please. Just so you know, I've got. Show it to you real quick here. Crypto Fire, thank you so much. And I'm giving that away tonight. If you guys saw the shirt that I just showed you, I'm giving that away to one random super chat supporter, just so you know. That'll be an extra large 3i Atlas shirt. As long as you are in Europe or in the Western Hemisphere in North America, maybe Australia, as long as you're in any of those areas, I can mail it to you for free. If you're in a more remote region and you the drawing, which will begin one random super chat person will get this. Then if it's a bit further away, then yeah, I may need some help on the shipping. Yeah, I'll tell you, it is over. Hello, Nokia. Thank you so much. Really, or not, what am I saying here? Norway. Thank you so much. Is it TJMSA? Thank you so much. I appreciate it. Yeah, I know. I don't know what's going on with the video quality here. I see it as well. We will continue struggling with it. Just so you know, the internet is having serious problems. There is another solar flare that's popped up. That's better. Yes. Let's go ahead and have a look at these fantastic animations from Digital Voodoo, and you can just listen to my voice instead, rather than looking at the problems that we were having come. H. Blake, thank you so much for the super chat. Really, really appreciate it. Okay, so I've signed on very early, and we're going to try to give you folks a little bit of lead-in information about what is likely to happen. And again, I apologize for the video quality. There have been a lot of internet problems in the UK as a result of of some new solar flares that have been hitting us. Thank you so much, Kizzy, for the super chat. Really appreciate it. Thank you. And thank you, Lunart, for the super chat. Boy, generosity streaming across you. Thank you so much. Daytime number, really appreciate it. Oh my God. Holy majoli. CB, I guess, CB Ohm, $100. Holy majoli. That blows my mind. Blows my mind. Thank you so much. I really, really appreciate it. I don't know what to say. That was a massive donation. Thank you. And thank you, Bridget. And thank you for the kind words. Really appreciate it. Man, these super chats are just streaming across. You guys are fantastic. Thank you. Now, there's going to be a way at the end of this broadcast. Producer will be linking you into some of these awesome new 3i Atlas animations that were created by Digital Voodoo, our awesome animator. The guy is so talented at what he does. Thank you, Keith. Really appreciate the super chat. All of these animations are courtesy of Digital Voodoo, and it'll be at the end of the broadcast. We'll be transferring over to these animations if you'd like to watch some of them. And then in the process, you will be helping him get to monetization. He's got all the subscribers he needs. He just needs a little bit more watch time, and then his channel will be officially monetized. We want to help Digital Voodoo tonight. So if you have some extra time, or heck, if you just want to leave your YouTube running while the animations are playing, that will help too. Phil, thank you so much. Really, really appreciate it. Thank you so much. And thank you, JT. Appreciate all of this generosity tonight. My God, blows my mind. So here's what is coming up. Here's what we can expect. Thank you. Grace. Yes. Hello, Grace. Nice to see you again. Okay, so here's what we can expect tonight in terms of the HIRISE images, assuming that's all that NASA gives us. But in my opinion, chances are we're going to get more than just the HIRISE images. I think chances are NASA's going to be unveiling a lot of stuff to us. And the reason I'm thinking that is the HIRISE images may not measure up to people's expectations. People may be disappointed with what they see tonight. John, thank you so much. Man, really appreciate your support. And thank you so much for ordering a shirt, a 3i Atlas shirt. So, hey, and here's the reason that people may be disappointed. The HIRISE camera is an impressive instrument, even though it's been out there for 20 years. This orbiter was deployed to Mars orbit a very long time ago. So this is an old instrument, but still a very sophisticated instrument with a sizable aperture. And of course, the more aperture you have, the more light gathering power your telescope has as well. And the more light it gathers, colors, the better the image is going to look. Because if you magnify an image, the more you magnify it, yes, that's right, Ray. Ray's Astrophotographies. I have indeed seen those images. Great channel, by the way. You guys should definitely check it out. Thank you so much for the super chat. Really, really appreciate it. So yeah, so the more you zoom in on a target, like a comet, for example, the less light your telescope gathers. So, of course, you want a lot of aperture. You want aperture more than you want magnification, to be honest. Pepsu, thank you so much. Really, really appreciate the support there. And they're not going to confirm aliens tonight, that's for sure. So the aperture on the HIRISE is much, much better than any of the other instruments that are currently orbiting Mars or on the Perseverance or the Curiosity rovers on the Martian surface. Much, much bigger aperture than any of those. So one would expect, given the fact that 3i Atlas passed much closer, about little over 0.2 astronomical units away from Mars, as opposed to well over 1.4 astronomical units for a lot of the images we've been getting lately. Given how much closer it was, and also Mars was photographing it from a different angle than we could possibly capture here with any of our instruments on Earth. With those combinations, one would expect that we could get a much better image. Ben, thank you so much. Really appreciate the super chat. Wow, you guys' generosity is fantastic out of the gate tonight. I'm super impressed. So one would think that everything would be a lot better there, but there are problems with the HIRISE and with all of the instruments that are orbiting Mars. All of these instruments were designed to photograph it's on the surface. They were designed to make these big compilations of images, take image after image after image after image, essentially an entire strip of the Martian surface, and then to assemble those together into a map or a larger image of the surface. You don't need time exposure capability to do that. As a matter of fact, you don't want to use time exposure on those kinds of photographs because Mars, although it doesn't have an extremely high albedo, that's reflectivity. It doesn't produce reflect a tremendous amount of light. It certainly it reflects enough to where a time exposure photograph would just wash out the entire photo. So they don't have time exposure capabilities. Wolfgang, thank you so much. Really appreciate it. Grace, thank you so much. Appreciate it. And Careless Whispers, boy, 3 back-to-back super chats. You guys are absolutely fantastic. We've already hit the goal, guys. So I'm giving away a shirt tonight. I am giving away a shirt to one random super chat supporter. Matthias, thank you so much. Really appreciate your support. You guys are incredible tonight. And John Morgan with a tenner. Thank you so much, mate. Really, really appreciate it. Okay. So without the ability to take time exposure photographs, that means that you're not gathering as much light. And again, remember what I said, light gathering capability when you're shooting nebula or comets or anything like that. You want as much light as you can get. And unfortunately, you're not going to get that. You're not going to get that without time exposure. Mike, thank you so much. Really appreciate you supporting the channel. Thank you so much. And hey, you know what? That's the great thing about this. All we're saying is that people should be able to express their opinions about what 3i Atlas is. If they have another theory, we should hear them out. Dave, thank you so much. Really appreciate the super chat. Boy, you guys are amazing tonight. Just amazing. So without the time exposure capability, HIRISE is not going to be able to get the best quality images at all. Again, HIRISE was not designed to do this. Thank you so much, Ride. Really appreciate it. Thank you so much for your support. So all of that being said, how are they going to get a photo of this thing at all? You know, if it was designed to take photographs of targets on the ground on Mars and not spaceborne targets, how are they going to get any kind of proper photo? Well, there's another problem. The HIRISE instruments, indeed pretty much all instruments orbit Mars are not designed to track anything. They can't track moving objects. And once again, we all know how fast 3I Atlas is moving. It's burning across the heavens, zooming through the solar system faster than any object that we have observed anyway has passed through the solar system before. It's just mind-boggling how fast this thing is going. And if you don't have tracking capabilities on your camera, then what's going to happen is as you take photo after photo after photo after photo, it's going to leave this long streak on the overall image that you're trying to create. And this is what happened with the Perseverance camera. The Perseverance image that was taken, that people were saying, oh my God, it's a cylinder. It looks like this long, bright cylinder. NASA's been lying to us. It's a tic-tac UFO. Well, no, what happened is the Perseverance camera was also not designed to track moving objects. And so they took multiple photos and stack them all together to increase the brightness of what we were looking at. And then they didn't adjust for the motion of the object across the heavens. So you instead had this streak across the photograph. It looked like a cylinder, but really what it should have been is this little bright dot. So what they're going to do with the HIRISE camera, first of all, they're not going to make the same mistake that they did with Perseverance. They're going to adjust for the movement of the object and then stack image after image after image after image until they increase the brightness significantly. And that will partially compensate for the instrument's inability to take a time exposure photograph. But to be clear, stacking images is a poor man's way of taking a time exposure photograph. It really, really doesn't do the job as well. David, thank you for being an angry advocate. I really, really appreciate that. So that being the case, what are we going to see tonight? To be clear, we are not going to see this big, spectacular image of 3I Atlas showing us exactly what it is. We're definitely, in other words, we're not going to get like one of these close-up views of a comet that we get from landers or orbiters that are approaching, or probes that we've sent to comets, etc. It never got that close to Mars in order to get those kinds of images. And also the HIRISE isn't capable, doesn't have the combination of light gathering capability and zoom in order to get those kinds of images. But what we will get possibly is a much better resolution of the nucleus, especially at the angle that HIRISE got the image, because as 3I Atlas is passing by, you may have less gas, ice, coma, whatever you want to call it. You may have less of that in the way, and you might be able to resolve the nucleus. If they manage to do that, then we at least know how big it is. And NASA may be able to announce with some degree of accuracy tonight exactly how big 3I Atlas is based on the images that HIRISE captures. But in terms of, are we going to see something that's 1,000,000 times more spectacular than the other images that we have seen up to this point? No. It's even possible that the Hubble images and James Webb images that have already been captured of this comet are going to, comet, maybe something else. Actually, I don't believe that it's a comet, not a comet as we understand it anyway. We're not going to see anything magnificently better than Hubble has already given us. But then again, that's my opinion. I may be wrong. It's I didn't design this instrument. All I've done is done a lot of reading about it and its capabilities. And by the way, HIRISE is significantly better than any of the other instruments that either NASA, ESA, or China has orbiting Mars. So yeah, it's definitely the best instrument that we had at our disposal to photograph 3I Atlas at the time. But it has a number of drawbacks, and probably the most significant drawback is the fact that it just wasn't designed to photograph objects in space, a nebula or a comet or an asteroid, anything like that. It was designed to photograph Mars from an orbit that's pretty damn close to Mars, to where you're already getting a pretty good shot without any magnification whatsoever. So just you want to make sure that we set proper expectations. All of that having been said, though, I would like to show you guys some images tonight, and we are going to start out with a leaked image. The producer, if we can put up the leaked image as it is called, and nope, that's not the leaked image, producer. The leaked image is the green one, spectacular green looking one with the other objects that appear to be zooming by around. And then there's also some footage that I have in conjunction with that, producer. But if you can grab the leaked image. Thank you so much, Robags. Really appreciate your support. Thank you for the $5. There it is. Okay. So this is supposedly a leaked image. And the reason I'm leading with this tonight is it's very, very important that you go only to reliable sources for these kinds of images. In other words, people who have a long-standing reputation as an astrophotographer, somebody who's done a lot of work prior to these sorts of things, or somebody like Avi Loeb, somebody who does responsible reporting on these. And let me tell you why this is absolutely not 3i Atlas. If you could go ahead and run the footage now, producer, that one piece of there, watch it. Here it comes. Here it comes. Are you kidding me? Yes. So once again, this was not even a particularly difficult image to fake. And as a matter of fact, the person who supposedly leaked it or whatever, I don't think they even created this animation. I think what they did took a still shot or a screenshot of an animation that somebody else created. They took the part that kind of looked like a comet and then threw it out there as a supposedly leaked image. And of course, as we can see, this is not even a particularly good CGI special effect. So again, just want to give you an example of how easy it is to fake these things, and how easy it is to even find. If you can find an obscure piece of animation out there and just take a still shot of you know, part of it at a long distance, as this particular fake was, man, I'll tell you, you can stir up a lot of talk on the internet. I can't tell you how many times I saw the supposed leaked image shared online. It was crazy how many times I saw it shared, discussed, and there was nothing legitimate about it. Thank you so much, Cora. Really, really appreciate it. Thank you so much for the support. Okay, so let's go ahead and look at some real photos here. Go ahead and just start with image 1 at this point, producer, and we'll go to another one. Okay, so this one here is a relatively recent image, and you can see once again this just how unique. If you're familiar with comets anyway, you can see how unique this image or this object actually is, because comets don't look like this. And I'll try to explain why. As far as the tail, quote unquote, to the that's heading towards the upper right-hand corner is concerned, this little wispy tail, that's a jet more than it is a tail. And again, we would expect to see a more prolific tail behind this thing than a jet. And also you can see that from the other side of 3i Atlas, there's this little bulge that's heading towards the lower left. That is the anti-tail, and it's not as well resolved in this photo. And move to the next one. All right, so this one we can see it a bit better. The anti-tail again is heading towards the lower left, and we can see the kind of spindly stuff of the what should be the regular looking tail heading off in the other direction. So tail is spearing off towards the sun to a distance of almost 1,000,000 kilometers. And then look at those little tendrils escaping from the other side, where the tail should be. We instead have all of these weird tentacles or tree roots or something like that heading off in the other direction. Again, this is not a typical cometary image. I'm not saying that there's no comet that's ever appeared like this, although when it comes to the anti-tail, it is definitely unique. And believe me, I've done so much research on this to be 100% certain. We have never seen a natural comet create these 1,000,000-kilometer lances heading out towards the sun, especially at this distance away from the sun, where the solar wind is powerful enough to just shred anything like that, or obliterate an anti-tail. And yet that's not happening. Let's move to the next image and maybe we can get a better look at this. Okay, so, and we also, in this particular image, we get to see what some of these stars that happened to be around it at the time. And again, you see it again, it's kind of a tail, but not really. And we're actually seeing several spindly parts of a tail rather than what like a conventional tail. It looks more like a trail of smoke or the kind of stream that we would expect to see behind a jet aircraft or something than a conventional tail. And also, as you can see, there's more than one of them. There are multiple jets heading out from away from the sun on this particular object. But again, you can see it a little better in this image, spearing out again kind of towards the lower left from the object is the anti-tail. And again, not as visually prominent, obviously, as the stuff heading away from the sun, but still, we're talking 950,000 kilometers at least is the length of this thing. And up to this point, the largest anti-tail, so to speak, that we've seen from and true anti-tail that we have seen from a natural comet is less than 100 kilometers in length. So we're talking 60, 80 kilometers, that sort of thing. And that's when a comet presents one side to the sun heats it up, and there happens to be pockets of ice and CO2 that erupt violently, and they manage to spear out towards the sun to a distance of about 60, 80, maybe 100 kilometers, something like that, but it doesn't get any further than that against the solar wind. This is unique. Spearing out to 1,000,000 kilometers is completely unprecedented. There are comets that have had longer anti-tails, but those anti-tails are optical illusions. All they are is when we cross over the orbital path of the comet, we see where the comet was and where the tail is. And sometimes the coma can appear in the middle of the tail as the result of an optical illusion. This is not an optical illusion anti-tail. These are true 1,000,000-kilometer lances spearing out towards the sun. And again, that is unprecedented in nature. And it's very difficult to figure out how this could possibly be happening with conventional sublimation. Let's go bring up the next one, producer. All right, this one, you can see it a little bit. This is a bit more close up. And in this case, the sun is to the bottom right of the image. And of course, we can again see these tendrils zooming away. And again, just look at it. These look like contrails from a jet, more so than what we would expect with a cometary tail. I looked at image after image after image after image of natural comets, and I have yet to be able to see any conventional tail that looks like that. It's a very unique. I'm not saying that it absolutely can't be natural. Sure, maybe, but man, that looks strange. And then once again, you see the anti-tail. It's not as visually obvious, but still very apparent in this image. It is spearing off again, more not quite towards the lower right corner, but just above lower right corner. Again, this very prominent anti-tail that's spearing out hundreds of thousands of kilometers away from the object. Again, these things really, really stand out. And again, if you have this kind of super obvious outgassing, you should also have a lot of NGA, non-gravitational acceleration. Let me explain exactly what that means. An object moving through the solar system is going to be affected by the gravitational pull of the various objects in the solar system. And for example, as it passed by Mars, even though Mars is not a particularly large planet, it passed close enough for Mars to have at least a little bit of an impact on its trajectory because of its gravity. And then as it passed the sun, obviously the sun having a massive gravitational pull, that had a substantial impact on its trajectory and also on its speed. As we have seen with all of the interplanetary probes that we send out, we use these gravitational flybys in order to increase the velocity of the object that's using the gravity of any planet it's passing by to increase the speed of the probe. The first time we really did that, that we really exercised that particular procedure, was with the Voyager spacecraft, Voyager 1 and Voyager 2. The speed of Voyager 1 and 2, when they were launched, were completely insufficient to reach the planets that they were trying to target in time. This was a very rare and unique period of time in the history of the solar system where Voyager 2, at least, had an opportunity to intercept Jupiter and also Saturn and also Uranus and also Neptune. All of those planets happened to line up appropriately in order for Voyager 2 to properly intercept all of them. But it wasn't going fast enough to intercept all of them as their orbits were arranged. Without gravitational flybys, there is no way that Voyager could have carried out the intercepts that it did at the time. And it utilized the massive gravitational pull of Jupiter and the almost equally massive gravitational pull of Saturn to continue to increase its speed. And so these days, we use gravitational flybys all the time. So that being said, we know how much gravity will affect the motion of an object moving through the solar system. When it moves further than that, when it speeds up more or its trajectory changes or something along those lines that gravity cannot account for, at that point, that is called NGA, non-gravitational acceleration. And most comets will experience at least some NGA, and that's because the outgassing, the violent sublimation of dry ice and water ice suddenly being converted into steam because of the heat of the sun. That acts sort of like a rocket engine, not nearly as powerful, but sort of like a rocket engine pushing on it. And so therefore, you're going to get a little bit of adjustment in trajectory. The thing of it is, this object had an unprecedented shift in its trajectory. It may not sound like a lot, about 100 kilometers per day or so out of position. That's about how far it moved, but that dwarfs the NGA of every other comet we have ever seen, with the exception of what are called sun grazer comets. There are certain comets that pass very close to the sun that get bathed in incredibly powerful heat. And under those circumstances, sometimes you can have really powerful outgassing that can result in an NGA shift that was sort of similar to what we saw with 3I Atlas, but still not as much. This is the biggest NGA shift that we have ever seen in the history of astronomy. And again, how did this happen, especially with an object as massive as 3I Atlas appears to be? And what makes this even more mysterious is the fact that 3I Atlas didn't shift on its trajectory at all. We saw lots and lots of outgassing for weeks and weeks, and yet there was no visible shift at all off its trajectory. It stayed arrow straight, which is unprecedented. Also, with all of that visible outgassing, it should have pushed it around a little bit, and yet it didn't. And then all of a sudden, when it reaches perihelion, boom, it has this big NGA shift. Again, doesn't sound like a lot, but at this point, because of this NGA shift, 3I Atlas is now thousands and thousands of kilometers off course from the course that it would have had it relied on gravity alone. Again, is that the result of an artificial propulsion system of some kind making a minor course correction? Was 3I Atlas passing through the solar system purely to take advantage of the sun, to give it a little bit of bump, a little bit of extra speed, but in addition to change its trajectory, so 3I Atlas didn't have to use any propellant itself to accomplish that, and then it needed just a little bit more of a bump in order to get on whatever course it needed to be on? Again, if you embrace the idea of an artificial object, that makes a hell of a lot of sense. And again, to make a shift at perihelion, a course correction at perihelion is the ideal point to do that. If it were an object under intelligent control, that is absolutely the point that you would make that kind of shift, because you're taking advantage of the sun's gravitational pull and also the heating of the sun, etc., in order to give yourself the maximum amount of thrust. And once again, now that it's completed this maneuver, whatever if you want to call it a maneuver, we are seeing loads of outgassing still. What appears to be loads of outgassing. Far more than JPL predicted. At this point, now that perihelion is done, and by the way, we didn't get to see exactly what happened at perihelion because 3I Atlas was hidden from our view behind the sun because of its trajectory and the time that it happened to arrive here. Again, interesting coincidence. But there's a lot of outgassing, what appears to be a lot of outgassing anyway, and with all of this outgassing, this thing should be shifting around again. And it isn't. Not at all. So very, very strange stuff going on here with this subject. Let's go ahead and see. Let's go ahead and have a look at the next one, please. Thank you, Svoliker. Really appreciate it. Thank you so much. All right. So once again, this is a little image that we have here. Again, get to see these odd looking trails behind it. Really, to me, these just look like contrails. They don't look like conventional cometary tails to me at all. And once again, if you look at not as visually obvious, but slightly down and to the right from the nucleus, you can see that anti-tail spearing out again. And we have seen this over and over and over. And yes, that is an interesting point. Thank you for bringing that up. Ray's astrophotography. Once our broadcast is done tonight, I strongly recommend you go and check Ray's astrophotography out. He lives in Austin, by the way, or close to Austin, which is where my daughter goes to college, by the way. He has gotten some really fascinating images of what appears to be rapid rotation. But also what I found to be very fascinating is this rapid rotation seems to be affecting the coma. The coma seems to be rotating around the nucleus. That shouldn't be happening. The nucleus doesn't have gravity, not nearly the necessary gravity to make gas and dust, whatever that happens to be surrounding 3I Atlas, rotate with it. And Ray did make a comment, by the way, that he has never seen a comet do this before. He's never seen this kind of visual phenomena with a comet. And I've gone through his videos. This guy has been photographing comets for a very, very long time. And incidentally, he calls it a comet. Just to be clear, he seems to very much believe that it is a comet. KY42, thank you so much for your support. Really, really appreciate that. So yeah, this spinning thing. And yes, I refuse to call it a comet too, by the way. I don't think that we have enough. Given all the weird anomalies with this thing, I don't think we have enough proof, enough data to confirm that this thing is a comet. Aside from the fact that it looks kind of like a comet, and it sort of maybe behaves like a comet. But man, I'll tell you, given everything else that we have seen with this object and the immense list of anomalies, I think that we really need to stop being so narrow-minded in our viewpoints. It may be natural, but if it is, it's very different from any comet we've ever seen. Thank you so much. Yes, goal achieved. Thank you so much. Appreciate it. By the way, again, to be clear, I'm giving away one of these shirts tonight. It'll be given out to a random Super Chat supporter. So we've already hit our goal. So I'll be giving out a 3I Atlas t-shirt to one random Super Chat supporter. So really, really appreciate that. Do we have any more images to look at, producer? If so, go ahead and bring it up. Yes, we do. Okay. So once again, this is, you can see a lot more clearly now in this image that's processed to pick up gas, dust, etc. a lot more clearly. You can see what I've been talking about here. A very prominent anti-tail, and then these spindly tails that are heading off behind the away from the sun. Again, we say behind, but it isn't actually behind. They're actually advancing in front of the object at this point. Relative to the sun, they're pointing away. But again, you have this very incredibly prominent anti-tail spearing out 950,000 kilometers towards the sun. Just mind-boggling. Thank you so much, Canada. Really, Gaytanch, I guess. Thank you so much for the $20 Canadian. Super appreciate that. You guys are fantastic. So we're about 20 minutes away from NASA going live at this point. Once again, I wanted to make sure that we get a good understanding of what we're going to be looking at, because chances are NASA is going to be showing us images that kind of look like this. Papa Dutch, could it be super dense? Yes, it could. It could. Thank you so much for your support. Appreciate it. And so therefore, it would generate a gravitational pull. Maybe. But here's the thing. If it is that dense enough to create a very noticeable gravitational pull that pulls gas and dust with it as it rotates, nothing should have been able to make it carry out the NDA maneuver that it did. Transporter room, thank you so much. Really appreciate it. Thank you. And Santa Annie, I think, is what's here. Thank you so much for your support as well. Thank you. Man, those are kind words. Thank you so much. We have such a massive crowd here. And by the way, you guys, congratulate yourselves. You have set a huge record on this channel. We have never had over 4,000 people in the audience. Not even close. This is the most I think I've ever hit is 2,000 maybe during a Starship launch. You guys are fantastic tonight. The number of you watching helps this channel out in ways that you can never fully understand. You guys are fantastic. Really, really appreciate your support. So yeah, we will see what we see tonight, but I would say odds are a lot of the images that we see from NASA are likely to be similar to those images that I've just shown you. We're going to see an odd-looking tail, maybe, an anti-tail, very possibly. We're not sure exactly how prominent the anti-tail was at the time that it was passing Mars. Hubble imaged it substantially before that in July, and it had an anti-tail then. Thank you so much, Fetch, for being an advocate, angry advocate. Thank you so much for joining the Angry Advocates. Just so you know, you get access to an exclusive Discord server if you are an angry advocate, or you're a Patreon supporter. Both ways gives you access to our Discord server, where we have a lot of folks who really know a lot about astronomy, a lot about space flight. There's a lot of expertise on my Discord channel. And of course, I'm there too. And on top of it, there's also do a lot of early release content whenever I can possibly get a video out early. The Patreon and advocate folks are going to get those early releases before anybody else. So yeah. I think it's going to be an interesting show tonight. Once again, though, we shouldn't expect these images to be incredibly spectacular. Fetch, thank you so much. Wow, you guys, I don't know what to say. I am so moved by your generosity and the kind things that you folks are saying tonight. Thank you so much. Oh, I just saw a quick question there. Yes, I'm pretty sure that was a joke, but yours is an ice giant, just to be clear. Uranus and Neptune are both ice giants. Just in case you guys didn't know that. All right, so let's continue with the discussion. So yeah, we got about 17 minutes before it goes live. Again, what we are going to likely hear from these people tonight is the standard explanation, the standard pat. It's a comet. It's definitely a comet. It represents no threat to Earth. By the way, I agree with that part of the explanation. I don't believe that 3I represents a threat to the Earth. And honestly, I never really did. I never thought that 3I Atlas is going to execute that Oberth maneuver around the sun and bear down on us. I honestly didn't even talk about it that often. I did mention it a few times because Avi Loeb definitely did as well, but it just didn't seem likely to me based on all of everything else that it had done, all of its behaviors up to that point, that it was going to execute some kind of radical change in direction. Just didn't seem to be very likely to me. That being said, though, when it did hit perihelion, it did definitely have an NGA event that dwarfs the NGA maneuvers of every comet that's come before it. Again, how did that happen? How is that possible with natural chemistry? Difficult to say. Again, I'm not saying it's impossible with it being natural. I'm not saying that there's no way in the world that it could be a natural object, but it's radically different from anything else we have ever seen before. Amanda, thank you so much for your generous support. Really, really appreciate that. So once again, we are going to get that pat information, guys. We are going to get that. It's a comet. Yeah, it doesn't threaten us. It is absolutely 100% definitely a comet. We are going to probably get that over and over again tonight. And again, I find that to be very frustrating given everything that we have seen with this object thus far. And again, we're even seeing digital voodoo is kind of showing us a little bit of why this is such a remarkable object, this prominent anti-tail. And again, when it was passing Mars, we're not sure if it had a prominent anti-tail at that point. Hopefully we'll find out tonight, but it did have an anti-tail significantly before the close approach with Mars. Both the James Webb Space Telescopes and the Hubble both captured an extremely prominent anti-tail pointed right at the sun without any conventional tail. There is no conventional tail at all. Again, one of the many remarkable things about this object. Definitely shouldn't be happening with a conventional comet. We have never seen a true anti-tail, as I've said a couple of times now. We've never seen, and by true anti-tail, in other words, an anti-tail that is not an optical illusion, something that is really jets of gas or dust or whatever the heck they are, spearing out towards the sun, laughing off the solar wind out to a distance of tens of thousands, hundreds of thousands, almost a million kilometers. Never, ever seen that before. Tim Anthony, wow. Thank you so much for your generous support tonight. Man, really, really appreciate it. So, yeah, I am fascinated. Looking forward to, once again, looking forward to seeing what they have to say. Just to be clear, I do have an astronomy background. I minored in astronomy at the University of Colorado. Definitely studied under some of the best astronomers. Some of the best astronomers in the world are at the University of Colorado. So I definitely have some background in the field. I'm completely uneducated on it. That being the case, though, I'm not a doctor of astronomy or anything along those lines. And I rely a lot on astronomers like Avi Loeb to give me my information. Carl Hughes, thank you so much. Really appreciate your support. Thank you so much. But I'll tell you, going hand in hand with my official education in astronomy is a huge passion for the topic over many, many years, over a number of decades, really. When I was a little kid, when I was 11 years old, I had what was called an Edmund Astroscan child's telescope. It was only a 4.5-inch aperture, just a tiny little thing, but nevertheless had some impressive light gathering power for being such a tiny. It was a tiny little red scope that you could just carry around with you. It was super easy. Papa Dutch, thank you so much. Really appreciate it. Maybe it is something like Rama from the famous Arthur C. Clarke novel. So I had an Edmund Astroscan, and I had an opportunity as a kid. In those days, no computers to guide your telescope to help you find targets in the sky. You just had to eyeball it to the best of your ability, and saw the Orion Nebula and the Andromeda Galaxy, the Ring Nebula, the Crab Nebula. I loved nebula. Nebula were just beautiful phenomena to look at in the night sky. It's just these gorgeous, gorgeous formations of gas and dust, which honestly, through the Edmund Astroscan was not particularly brilliant, but nevertheless very obvious, especially the Andromeda Galaxy. As a matter of fact, if your eyes had better light gathering power, you could see the Andromeda Galaxy. The Andromeda Galaxy traverses a larger area of the sky than the moon. But the reason you can't see it, it's an immense galaxy. It's double the size of ours, of the Milky Way. But the reason you can't see it is because it's hundreds and hundreds of thousands of light years away. And at that tremendous distance, it's not giving enough light off for your eyes to be able to pick it up, for your eyes to be able to see it. So the only way to see it is through a telescope that has a lot more light gathering power than your eyes do. So yeah, the Andromeda Galaxy is definitely one of my favorite things to look at through the telescope, this little beehive of light. Thank you so much, Carlo. Really appreciate it. And hello to you in Croatia. So, okay. So all that being the case, the instrument that photographed 3I Atlas as it made its pass by Mars is way better than the Edmund Astroscan, that's for sure. It's a much, much bigger aperture than that. Full Raven Lisa, I think. Thank you so much for the £2. Really, really appreciate your support, and I will definitely stay angry. So it definitely has a substantial aperture, but in many ways, it's going to be pretty similar to looking through a backyard telescope because it's incapable, as I said earlier, of taking time exposure photographs. The only way to get a really good look at a comet, nebula, galaxy, whatever, is if you have a lot of light gathering power in the instrument, and you're going to much more light if you use a time exposure photograph. But the HIRISE instrument and the others that orbit Mars were never designed to do that. There's no need to take time exposure photos of the Martian surface. And so they don't. And so they don't have that capability. So as a result, comparing this to, say, the light gathering power of Hubble, there's no comparison there at all, guys. Not even remotely. Hang on, gonna take a little drink here. So that being the case, we should prepare ourselves for these images to not be especially spectacular. But at the same time, 3i Atlas was very close, just over 0.2 astronomical units away from Mars, way, way closer than any instrument that's observed it from here on Earth. So that does make a difference. And also, it's going to be looking at it from an angle that we have never photographed it from before. Obviously, the ESA instruments from on the Mars Express, those, and also the Perseverance, that sort of thing. They got some photos, but again, those instruments did not have a very big aperture, did not have a whole lot of magnifying power, and were not designed for this sort of thing anyway. So yeah, I'll tell you, it's we're not going to get the best quality out of this because of its inability to take time exposure photographs. And again, the way they're going to get more light out of 3i Atlas, out of the target. Thank you so much, Fetch. Really appreciate it. Like to Vandals is unambiguously alien and they ignore us. Yeah, I wouldn't be surprised if they did ignore us if it is an artificial object. So the way they're going to get this without a time exposure photograph is to stack image upon image upon image upon image. They're going to have to adjust for the movement of the object. 3i Atlas is moving very fast, moving faster through space than any object that we have ever observed before. Significantly faster. And so they'll have to stack all those images on top of each other, adjust for the movement, and then we'll hopefully get a brighter and more detailed image. Papa Dutch, thank you for being an advocate. Really, really appreciate you joining the family. So that being said, even if you stack a lot of images to increase the light, that is still a poor man's time exposure solution. You're just not going to get as good of a photo as you would with a conventional time exposure. So unfortunately, tough to say if how good of an image we're going to get, but we should be prepared for a little bit of a disappointment, maybe. Flannel Pillowcase, thank you so much. We're living in a history where this event will be revisited for a long time in the future. I think that's likely. I mean, a lot of people keep saying that, oh yeah, the Vera Rubin Observatory, once it's up and at full speed, etc., and searching the skies, we're going to see lots of these things. We're going to see at least a couple of them every year, maybe even one a month. I really doubt that. And the reason is we have been watching the sun for any comets that might be passing it for over a decade now, actually substantially longer than a decade. Oumuamua was spotted. That's the first confirmed interstellar object that we've ever seen, and that was in 2017. In that time, we've been looking very, very hard for any objects like it, especially objects that pass by the sun, and so therefore are a lot more noticeable, a lot more brilliant, especially their comets, a lot more brilliant when it passes right by the sun. And we can definitely see those sorts of objects, and we have yet to see anything like 3I Atlas since we found Oumuamua back in 2017. And once again, we have multiple instruments trained on the sun looking for these types of objects. Thank you so much, Ryan. Really, really appreciate your support. Thank you so much. And yeah, let's see, Ubaldo, I'm sorry, I'm not going to be able to pronounce that, but thanks for being an advocate. Really appreciate that. We're adding a lot of angry advocates tonight. And by the way, again, it gives you access to an exclusive Discord server. So yeah, looking forward to meeting all of you on the Discord server. All of you new members, thank you very much for supporting, and all you folks who've been supporting us with super chats. Once again, I'm giving away a 3I Atlas shirt tonight to one random super chat supporter. So looking forward to the drawing. Again, that will take place at the end of the broadcast, so please make sure to stay tuned. Man, we have a huge crowd. Over 4,600 people in the audience. Again, you guys have set a huge record for this channel. Never, ever, ever have I had an audience this big, not even for the first launch of Starship or anything like that. This event is huge in as far as astronomy enthusiasts are concerned anyway, or alien enthusiasts, UFO enthusiasts, whatever. Obviously, the enthusiasm for this moment and for any news about 3I Atlas is intense, and that's such a great thing. That's such a fantastic thing that we have this curiosity, this sense of wonder that exists in the population of the world when there are so many things to distract us, so many negative things in the world to distract us, and instead we're focusing on this, and that's just fantastic. Guys, I'm really glad that you have joined us here tonight. Let's see, what do we have? Blue Joe, thank you so much. Why do we have small sensor platforms at L points throughout the solar system? Good question. I'll answer that in a second. Any word on the new Borisov? Not to my knowledge, no. But let's go ahead and answer that. It would make a lot of sense to put instruments, observational instruments at different Lagrange points. Lagrange points, once again, being natural solar system parking lots where the gravitational pull of various objects cancel one another out, meaning that they'll stay put in that area where the gravity is canceled out. So it's a very good, stable place to put things like the James Webb Space Telescope, for example, is at a Lagrange point. And in addition to that, the Escapade spacecraft heading to Mars, those are sitting at Lagrange point 2, which again is a location where the gravity of the sun and the Earth balance one another out, and they're staying put. Producer, NASA should be going live here really soon, so we'll be bringing you NASA coverage as soon as they go live here. But we are very close. We're coming up to, yep, looks like we're going to get the stream going. Here we go, guys. NASA's going live. Of course, we can't say anything or can't bring you anything until their copyright music is done. David, thank you so much for the tenor, my friend. Thank you so much for your support. So we're waiting to see what happens with, we're waiting for NASA to go live. Producer, can you go ahead and pipe in the audio whenever possible? And thanks very much. And so, yeah, in any event, I'll keep talking until they come on. Thank you so much, Triaxium. Thank you so much for the tenor. Really, really appreciate it. Thank you so much. So once again, super excited, guys. Super excited for all the enthusiasm. Oh, NASA's live. Let's bring you NASA.
Experts who are excited to share the latest images we have of the interstellar comet 3I Atlas. 3I means third interstellar, and Atlas refers to the NASA-funded Atlas Survey Telescope, which made the discovery. We are joined today by Amit Kshatriya, NASA's Associate
Producer,
Administrator.
if you can pipe
Nikki
in the
Fox,
audio.
Associate Administrator for NASA's
possible.
Science Mission Directorate. Sean Domagal-Goldman, Director for the Astrophysics Division. And Tom Statler, Lead Scientist for Solar System Small Bodies in the Planetary Science Division. We'll be taking questions from the media on the phone bridge and through social media, but before we get started, let's learn more about this fascinating comet and share some images. Amit, kick us off.
Hi everyone, America leads the way in space exploration. As Courtney noted, a NASA-funded telescope, the Atlas Survey Telescope in Chile, first reported observations of the comet on July 1st, 2025 to the Minor Planet Center. And NASA has been tracking and studying Comet 3I Atlas ever since. We're here today to give you the latest of what we know about Comet 3I Atlas and what we still want to know. But first, what is a comet? It's a small, natural solid body that is a combination of rocky and icy material that evaporates as it warms when it's close to a star, like the sun. But to start with, I'd like to address the rumors right at the beginning. I think it's important that we talk about that. This object is a comet. It looks and behaves like a comet, and all evidence points to it being a comet. But this one came from outside the solar system.
Here we go.
Which makes it fascinating, exciting, and scientifically very important. This is only the third interstellar object like this that humanity has ever found. And a little bit more about the rumors. I think it's very important, and I'm actually very excited that a lot of the world was speculating about the comet while NASA was in a period where we couldn't speak about it due to the recent government shutdown. I think what I took away from that whole experience and watching that as we were working during the shutdown was just how interested and how excited people were about the possibility of what this comet could be. There was a lot of speculation about what it could be, but what I think is really awesome is that folks were interested in this incredible finding that we observed and that that came from the heavens, and what that means, what it could mean about how magical the universe could be. It expanded people's brains to think about how magical the universe could be. And I'll tell you, here at NASA, we think that every day. And so it's really great that you were able to join us while we were not able to comment because of the shutdown constraints about what that comet is, because we think the universe is a magical place, and we spend your treasure and we spend all of our time trying to make sure that we explore that and share with you as much as we can. In fact, we want very much to find signs of life in the universe. In fact, just a few months ago, we were with you and we talked about what we think might be the signal from ancient life on the surface of Mars from our amazing machines that have been roving the planet for 30 years to look for those things. That is something that's really important for us to learn about and discover. It could be an amazing discovery if and when we can confirm that. But 3I Atlas is a comet. So my colleagues from the Science Mission Directorate will go through the images in detail, but just to give you a peek, here's one of the images from the closest physical instrument we had to the comet, from the HIRISE instrument on our Mars Reconnaissance Orbiter, taken on October 2nd as the comet sailed by at a distance of 19 million miles from the instrument. You can see that Comet 3I Atlas looks like a fuzzy white ball. That ball is a cloud of dust and ice called the coma, which is shed by the comet as it continues its trajectory towards the sun. I'll leave it to my esteemed colleagues to share further details, and I'd like to introduce you to the head of NASA Science, Nikki Fox.
Thank you so much. It is such a rare opportunity for us to be able to observe this interstellar comet. And NASA Science has been given this really, really exciting opportunity to do it, and literally from the moment of its discovery. Just like Amit said, comets are tiny cosmic snowballs. And by studying them, we can learn about the environment from, basically where they formed, where they came from. This one came from a different environment from our own, and so we're already starting to see some really interesting differences to comets from our own solar system. 3I Atlas, as you heard, is the third known interstellar object to pass through our solar system, the first one being identified in 2017. While these types of interstellar objects have long been predicted, we are just beginning to be able to find them thanks to the newest technologies with our network of Earth-based telescopes, which are designed to find small, fast-moving objects in space. The NASA-funded Atlas Survey Telescope, which made the discovery, is part of NASA's Planetary Defense Network. Our telescopes are always watching the skies to keep us safe, and in doing so, they occasionally make major scientifically interesting discoveries, just like this one. Right away, of course, NASA's Planetary Defense Coordination Office they studied it, and they established that 3I Atlas is not a danger to Earth. In fact, it's at least twice as far away as the distance between the Earth and our sun. On October 30th, the comet itself reached the closest it will ever be to the Sun when it crossed just inside Mars's orbit, which is why the image that Ahmet just showed, he noted it was the closest instrument physically to the comet, because the comet was right inside the orbit of Mars. Earth was on the opposite side of the Sun, which is about as far away as our planet can possibly be from Mars. It's been clear from the moment of discovery that the comet was going to pass on the opposite side of the Sun from where the Earth is. However, it was also clear that its positioning behind the Sun was going to make observations from Earth very, very difficult. And that is why we are so happy to have our incredible fleet of NASA science spacecraft all across the solar system. And boy, were they ready for this event. NASA's science assets on board our missions have provided the United States the unique capability to observe 3I Atlas almost the entire time it passes through our celestial neighborhood. Everything NASA science does is interconnected, and nearly 20 mission teams have been working together to really rise to this challenge. 20 mission teams, by the way, and counting. Everything we're learning about the comet is possible because of the distribution of all of the different instruments on our spacecraft with different capabilities. And I'll note that for some of them, we've even pushed our scientific instruments beyond their normal capabilities, beyond the things that they were designed to achieve, to allow us to capture this amazing glimpse at this interstellar traveler. In other words, we can study this comet so well because we have many different assets in different locations, observing things in different wavelengths, in different ways, with different instruments, each set of observations providing a different lens for understanding objects in the sky. So NASA's science team has kept watch on 3I Atlas for nearly its entire journey through the solar system for the first time ever. So I'll just quickly go through the timeline of which NASA spacecraft have observed the comet thus far, and we're still going. There will be more opportunities to observe this comet as it continues its journey through the solar system, passing the orbit of Jupiter in spring of 2026. So the NASA assets that are gathering observations of 3I Atlas include Hubble, the James Webb Space Telescope, TESS, SWIFT, SphereX, Perseverance Mars Rover, Mars Reconnaissance Orbiter, MAVEN, Europa Clipper, Lucy, Psyche, personal favorite, Parker Solar Probe, Punch, Stereo, and ESA, NASA's SOHO mission. And I'll note that Parker Solar Probe's data were just downloaded yesterday, and indeed, we did catch several glimpses of this amazing comet. The scientific community is hard at work analyzing these images, and everyone, as always, is welcome to take a look. At NASA, we embrace open science. We make all of our data available to the public 24/7, and we invite, in fact, we really want you to tell us what you're observing and what you think about what we're looking at. We're still learning even about what questions we still need to ask, and this, of course, is the scientific process in action. All the data go to a public archive. We get those images as soon as we're able to from all of our eyes in space. As always, I am excited to see what new things we learn about our friendly solar system visitor in the days and, in fact, the years to come. So now I'm going to pass over to Sean. He's going to tell you about what our astrophysics missions have seen. They, of course, were some of the first things to look at the comet, and images from several of them have been available since the beginning of the summer. So I'm going to ask you to set the stage for us, tell us what we've already seen before we hand over to Tom to tell us all the new stuff. Take it away, Sean.
Thanks, Nikki. Happy to. To give you some background, NASA's astrophysics missions, like all our missions, they are designed to do things that would otherwise be impossible. In this case, our nation's space telescopes stare deeper and more sharply into the universe than any other observatories in the world. And that means we're often the first to follow up and study near-Earth objects or comets like 3I Atlas after they're initially detected. That same powerful gaze that lets these telescopes see distant galaxies, those little red dots you might hear about, they also allow us to observe details about objects like 3I Atlas a little bit sooner. And the earlier we learn about these objects, the earlier we can share this information with the world. including the science community and our partners across the planet that often have ground-based assets or other space-based assets, so that they can conduct additional observations with their telescopes. In this case, our astrophysics missions came together to take advantage of this rare opportunity to study this comet that came to us from outside the solar system. From our flagship space telescopes to smaller missions like TESS and SWIFT, they all have, as Nikki said, different complementary capabilities. They don't just do things that would otherwise be impossible, they do things that even our other great telescopes can't do. So every time we add to the fleet, we add additional capabilities that expand the realm of the possible. In this case, it let us refine the orbit of this structure early on, determine what its structure is and what its composition is, what it is made of. It's a beautiful illustration of why we have not just one space telescope, but a fleet of them, because every one member of that fleet specializes in a different kind of information, contributing a different piece of the puzzle to the total understanding we have from the fleet as a whole. So for example, Old Reliable, NASA's Hubble Space Telescope, celebrated its 35th birthday earlier this year. And not too long after that, in July, it looked at 3I Atlas, not long after we discovered it from the ground. At this point, 3I Atlas was about 277 million miles from Earth. And what Hubble's images revealed was a few things. First, a teardrop-shaped coma of dust coming off that solid, icy nucleus of the comet itself. From these data, astronomers were able to more accurately narrow a few things. Importantly, the size of the nucleus. We now know it's between, at that point actually, we knew it was between 1,400 feet in diameter up to as large as 3.5 miles in diameter. And Hubble also saw that the comet was losing dust, and not just losing it, but losing it at a rate consistent with other previous sun-bound comets that originated from within our solar system, consistent with the physics that we figured out from watching those objects. Now, the last thing Hubble did is it gave us a better understanding of the orbit of this object. Tell us not just where it was, but where it was heading, so we could point other observatories at it, such as the James Webb Space Telescope. We added this to our fleet early in this decade. We didn't have it when the last two interstellar comets came around. And what James Webb did, and its companion SPHERE-X, which we only launched at the beginning of this year, is it added infrared observations. The power of infrared observations is, these are colors we can't see. They're redder than what our eyes can detect. And infrared light is particularly good at helping us understand the composition of objects. We can see little molecular fingerprints from the things that the objects are made of. So with these infrared observations with James Webb and SPHERE-X, we detected an abundance of carbon dioxide gas in the comet's coma and in the bright cloud of gas and dust surrounding that comet as it approaches the sun. Those molecular fingerprints I mentioned, those are the little like science wiggles you might see in the top right of these images. We now know from seeing those science wiggles, those fingerprints of those molecules, that the comet has a nucleus rich in carbon dioxide as well as the presence of water ice. Now, the ratio, like we can not just say that these things are there, we can also say, what's the ratio of carbon dioxide to water? And we now know that. We know it's larger than what we usually see in solar system objects. But there's a lot of natural explanations for that. For one, the carbon dioxide is going to kind of bake off that comet earlier on when it's far away. But there's other well-understood processes that could also explain it. I'll just, to put this in context, every time we look beyond our solar system and we look at the ratios of carbon dioxide to water, we see, whether it's a star or a planet, different ratios than we see in the solar system.
I can see that what's being posted. The problem is I've been so distracted.
So it could mean, and this is the last theory of
why
those ratios could be different, that ices could have been exposed to higher levels of radiation than comets in our own system. Or, as I said before, could be that the comet just formed from a region where carbon dioxide ice was particularly abundant and different from our solar system. Other missions like our SWIFT spacecraft, which studies X-rays and gamma rays, have also observed the comet. Teams even looked back through data from our TESS mission, which was designed to look at exoplanets, and found observations of the comet as early as May. That information is helping us understand the comet's history before it got closer and when those other observatories pointed at it once we knew where it was. Now that the comet is near, relatively speaking, our planetary and heliophysics missions have joined in to tell us more. And now I'm going to turn it over to my colleague Tom Statler to talk about some of those new images.
All right, thanks very much, Sean. Before we get started, I just want to remind everybody of where we are, who is where in this play. As you saw in the animations while Nikki was speaking, the sun, of course, is at the center of our solar system. The planets are orbiting around the sun, and in this case, Comet 3I Atlas has come through on a trajectory in the opposite direction and has arrived at its closest point to the sun when the Earth was on the wrong side for us to conveniently observe. But Mars was on the correct side of the sun, and our Mars assets were able to observe the comet, and also several of our other spacecraft were on the correct side of the sun. So the scientific community is really excited about the comet and about these new observations. I'm tremendously excited to help share them with you today. This is a new scientific opportunity, and it's a new window into the makeups and histories of other solar systems. We're just beginning to learn about these types of objects and figure out what are the right questions we should ask about them. Now, let me start by going directly to what we were able to see at the beginning of September, when Psyche was able to see the mission. So before that, though, in August, we organized a workshop. We organized a coordination session for the missions across the NASA fleet that had good opportunities for potentially observing 3I Atlas, so that we could all share observing plans and knew what was going to be possible with our assets. I can't emphasize enough now how, thanks to the cooperation of so many mission teams, we will be accumulating a wealth of data on this comet that the science community will be digging into for years. Now, let's go back to September, and I can show you a sampling of the images collected by our different mission teams. To set the context, you're going to see a comet that's a small body with a coma around it, basically a fuzzy blob. Now remember, space is big. Nothing is ever really as close as you like, and all of these observations are very, very difficult. It's a little bit as if our NASA spacecraft were at a baseball game, watching the game from different places in the stadium. Everybody's got a camera, and they're trying to get a picture of the ball, and nobody has a perfect view, and everybody has a different camera. Now, let's return to September and see the first images from the Psyche spacecraft. NASA's Psyche mission acquired 4 broadband black and white images of the comet
assuming
over the
I
course
can
of
stay
8 hours on September 8th and 9th, 2025. The comet was about 33 million miles from the spacecraft at that time, and you can see in the image the large frame where the comet was seen at different times. Down in the bottom left is a blow-up, a stack in addition of all of those observations. The Psyche spacecraft is on its way to an asteroid in the main asteroid belt that's also named Psyche, and these images were the first captured from this perspective. Now, if you think in that lower left you're not seeing very much, just wait a minute, you'll see more. Now, the following week in September, the Lucy spacecraft observed the comet from the opposite direction. So let's take a look at the Lucy image. This is another broadband black and white image made by adding up a series of individual exposures that were taken on September 16th. Lucy is on its way to study asteroids that share Jupiter's orbit around the sun, called the Trojan asteroids. Lucy was 240 million miles away from 3I Atlas, which is circled in the center, when its high-resolution LORRI camera caught the comet. You can see the comet's coma, the fuzzy halo of gas and dust surrounding 3I Atlas, and its tail, the smudge extending to the right of the comet. If you were the Lucy spacecraft looking at the comet from this angle, the sun would be a little bit over your left shoulder, and so the comet tail is pointing away from the sun, as we've seen many times before in solar system comets. For scale, this image spans about 1/3 the width of the full moon as you'd see it on the sky. Of course, at the distance of the comet, that's a much, much larger region of space than the moon. Now, this looks a little different from the Psyche image. Part of that is because the cameras are different, and part is because of the ways the Psyche and the Lucy teams decided to show their images. But also, it's because we're seeing the comet from different directions. Seeing a comet's coma in different lighting geometries, with the sun coming from different directions, is one of the key ways to learn about the physical properties of the dust that's been launched off its surface. And I want to emphasize that you do not get these views unless you have spacecraft farther from the sun than the comet is, so that you can see it backlit. We could not get this view from the vantage point of the Earth. So combining the data from Lucy, Psyche, and Earth-based telescopes, scientists are hoping to better understand both the three-dimensional structure of the comet and the nature of the dust. It's a rare opportunity to compare ancient dust from a distant solar system to that from our own. Now let's go to the next picture from the MAVEN spacecraft at Mars. At the beginning of October, 3I Atlas passed within 20 million miles of Mars, which gave our Mars spacecraft an opportunity for a close-up. And earlier you saw the image that Ahmed shared from our Mars Reconnaissance Orbiter. MAVEN is another Mars orbiter that has been studying the Martian atmosphere since 2014. Now, this picture is not a direct picture of the comet itself. It's a spectrum. You're seeing the science wiggles that Sean was just talking about. This is some of those science wiggles where the instrument, the spectrograph, the ultraviolet spectrograph on MAVEN, has looked at the comet and also split up the ultraviolet light according to color. So you're seeing three different bands in this image. On the right, you're seeing emission from hydrogen gas in the atmosphere of Mars. In the middle, there's a fainter band indicating that's coming from hydrogen gas in interplanetary space. And on the left, that blob is the signature of hydrogen gas coming from comet 3I Atlas. It's a little blob rather than a big streak because the comet is a small object in the sky relative to great big gigantic Mars and interstellar space that fills the entire field of the instrument. That definitely tells us, first of all, that the comet is there. If there were no comet, there would be no little blob on the left side of the image. But it's also telling us it's one of the many ways that we're able to discern the chemical composition of 3I Atlas. And in this particular example, it's showing us the hydrogen gas that's coming off of the nucleus. Now, MAVEN's observations, combined with the earlier observations by Swift and Webb that Sean spoke about, will help determine the water production rate, how much water vapor is released from the comet when the comet is warmed by the sun, which provides insight into the formation of the comet and its journey through our galaxy. Now, the European Space Agency and NASA's Solar and Heliospheric Observatory, or SOHO, also successfully imaged 3I Atlas from October 15th to 16th after it had passed Mars. And SOHO spotted the comet crossing its field of view from approximately 222 million miles away, or more than twice the distance of Earth from the Sun. Comet 3I Atlas was expected to be too faint for SOHO to see, but this result was made using detailed image processing and overlaying, or we call it stacking, subsequent telescope images. And this image highlights the value of spacecraft and instruments designed to look directly toward the sun, as Nikki was saying before, not only to study the sun, but also to have the ability to see other objects crossing, in this case, behind the sun from the telescope's point of view. You'll be able to see the rest of the images on our 3I Atlas website, go.nasa.gov/3I-Atlas. And there will be more to come. Not all of the data have been downlinked yet through NASA's Deep Space Network, and there are more observations still in work. And also, it's a long way from where we are today, seeing the initial images, to then making sure that they are accurately calibrated and processed to do science with, and then doing the analysis, combining the data sets, understanding them, and finally producing the scientific understanding, the knowledge of what this all means, which will be published in peer-reviewed scientific journals. But the answers will come later on. We are still at this phase, very much in the state where we're figuring out what are even the right questions to ask about interstellar objects. This is a snapshot of where we are very early in the scientific process. Okay, back to you, Courtney.
All right, thank you all for your opening remarks. We'll go ahead and start the question and answer portion of this event. Just a reminder to our media on the phone bridge to press *1 to enter the queue and ask your questions. We'll take our first question from the phone bridge from Marcia Dunn with the Associated Press.
Yes, hi. Based on your latest observations what more can you tell us about the potential shape of the comet? Can you fine-tune any more on how big or small it might be, origin, all that sort of thing? Thank you.
Thanks for that question. There's a lot of territory to cover there, so let's see what I can do. The size of the nucleus still has yet to be pinned down. The best data are still from the Hubble observations that Sean was talking about. So we're still right now in that range of somewhere in the vicinity of a couple of thousand feet to a couple of miles diameter, but we'll get better on that one. The shape of the nucleus is also difficult to pin down because generally we're not resolving it in our observations. It's obscured by the dust, and especially it's obscured by the reflected sunlight off of the dust in the inner part of the coma. But what observers from the ground have been able to do is observe the brightness of the center of the comet over time to see if there's a modulation of that brightness that would be an indication of rotation. And it's very difficult to discern. So what it's looking like so far is that there's not a big, the shape of the nucleus is not very far from being round. It's not, doesn't seem to be a big, or at least we're not seeing signatures of a very elongated object yet. There's a lot still to come there. I think you were also talking about origin. It would be great, it would be fabulous if we could trace back the incoming trajectory into the solar system and trace that back and figure out where it came from. But things are not quite so simple. Our galaxy, as Sean knows, is a big and complicated place. And the sun and all the other stars in our galaxy are in orbit around the center of the galaxy. And so 3I Atlas has been in interstellar space for a very long time. There is circumstantial evidence, given how fast it has come in to our solar system, that it came from some very old population, some solar system around a very old star. Quite possibly, we can't say this for sure, but the likelihood is it came from a solar system older than our own solar system itself, which gives me goosebumps to think about, frankly, because that means the 3I Atlas is not just a window into another solar system, it's a window into the deep past, and so deep in the past that it predates even the formation of our Earth and our Sun.
All right, we'll take our next question from the phone bridge from Bill Harwood with CBS. Bill, if you're talking, we can't hear you.
Try me again. This is Bill Harwood again. Can you hear me?
We have you loud and clear.
Okay, thanks. Sorry about that. Amit mentioned the rumors that were, kind of scurrying around about this thing in the weeks leading up to this briefing today. I have two questions for anybody who would care to answer. One is, did any of you seriously, did you take seriously the proposition from some that this could be an alien spacecraft? I doubt you did, but I'm asking the question anyway. And number two, is there any evidence you see in any of the data you have that would fit an explanation like that? Or as far as you're concerned, does all of this data say conclusively that this is simply a comet that happens to be passing through the solar system? Thanks.
So I'll take that one, Bill, and thanks for the question. We love all of the different science and all of the different kind of hypotheses into what these things can be. When you start seeing something, you just got to point. It's natural to wonder what it is. And we actually love, as Amit said, we love that the world wondered along with us. And that's such a cool thing. We certainly were able, because of the measurements that Sean described from the astrophysics telescopes that immediately turned on this object once we found it. And even, I was interested, I just learned that we'd actually gone back and actually seen it before we even found it. So that was super cool. I just heard that from Sean. But, we were very quickly able to look for sort of, the easiest thing to do, I'll put it in a different way, is if you understand comets pretty well and you understand asteroids pretty well, you kind of know the signatures that you're looking for, and so you can sort of look for those quickly and tick them off and say, yep, it really does behave like a comet. The interesting thing that, Tom, I know if I throw this to him in a second, he's going to geek out about it. But the really cool thing about this is the differences, because it comes from somewhere else. And that's why we're so excited about it. It's only the third time that we've been able to identify and track something coming from outside our own solar system. We've long predicted these things occur, and now, of course, we know better how to look for them, and we now have this amazing Atlas array. We're expecting we'll find a lot more of them, but it was quick. We were quick to be able to say, yep, it definitely behaves like a comet. We certainly haven't seen any technosignatures or anything from it that would lead us to believe it was anything other than a comet. But the super cool thing is not that it's exactly like all the comets that we see in our solar system. It's the differences that are so tantalizing for us as it gives me goosebumps too. It could be from something that existed before our own solar system. That is so cool. It's from something that predates even our own star. Yep, it's going to look different because it didn't come from our solar system, and that's what makes it so magical. You want to geek out a little bit, Tom?
You were geeking out so expertly, Nikki, to begin with. So that was fabulous. But that's exactly right. I mean, things from other places, we naturally expect them to be different from our own homegrown variety. And I like to imagine if you're fortunate enough to have grown up in Hawaii and you only drank Kona coffee, you love your Kona coffee, and then somebody says to you, well, gee, have you tried Sumatran? You're going to say, well, do you expect it to be different? And they'll say, why don't you try this? And you try it and you say, wow, that's really different. And you realize, well, I expected this to be different because it was from someplace else. It was a different environment in Sumatra. Now, does that one sip of coffee tell you everything about the weather in Sumatra and the soil and the people who harvest the coffee? Bless them. Of course not, but it's different, and yet it's still coffee. And that's what we have in this case. We have a cometary body. It behaves, it resembles the homegrown comets that we have in our solar system, and yet it's excitingly different in particular ways. It does the same thing comets do. It evaporates carbon dioxide gas. It evaporates water. But it's evaporating more carbon dioxide compared to water. So that's a very interesting thing. Comets evaporate dust, and the dust is broken down. The minerals are broken down by the ultraviolet light of the sun. And comets, we know comets put out nickel, they put out iron. That's what comets do. This particular one is putting out more nickel than iron. That's really interesting, really remarkable, and something to be studied in the future. So we're always interested in new ideas. We're always interested in new suggestions, and all ideas are good when they're born. But those that stand the test of time, those that stand up to testing, those that are supported by the evidence, are the ones that survive.
All right, we'll take our next question on the phone bridge, and that one comes from Matthew Glasser with ABC.
Good afternoon. Thank you for doing this. Tom mentioned that the answers will come in time. I'm curious about what are some of the hopes that we might discover from this comet. What might it tell us about our planet, about our solar system, about the universe? Are there key things you're looking for as you start to analyze this data, and are you excited about anything in particular when it comes to better understanding how things are working out there?
Sure, I can take that. Every new object we discover is a new piece in the puzzle. What we're trying to do always is to understand the universe. That's part of the NASA mission, is to understand the solar system, understand the universe, understand the origin of planets, the origin of life. And that is a huge question, and we get little bits, little clues to parts of that puzzle, and we start trying to put that puzzle together. We have gained tremendous amount of information from hundreds of years of astronomical observation and from decades of in situ spacecraft observation has revealed our planets as actual places, not just points in the sky that you could barely see with your own eyes. We've learned about comets and asteroids, and we're beginning to put together a picture of how all of those planet-forming minerals and planet-forming ices came together to form our planets, and how our solar system changed over time. Just one example, we get a fascinating clue from the objects like Pluto that we've been discovering since the 1990s, the trans-Neptunian objects, the way they are distributed through space in the outer solar system show us clues to how the orbits of the major planets may have changed over time in the early solar system. A fascinating thing, and questions that we would never have thought to ask before we knew about these trans-Neptunian objects. Now, interstellar objects, like I said before, are new windows, and it's windows that we've never even looked out of before. So what we're going to find is way too early to predict, but I think we're getting a hint of the breadth, the wide spectrum of conditions that existed in different parts of the galaxy, in different solar systems, where the compositions, the elemental abundances, the mineral abundances may have been very, very different. It would be a different picture if we were seeing the first 3 interstellar objects and we'd say, gee, those look exactly like our homegrown comets. That would have been really interesting, and we would have said, well, maybe our galaxy is a boring place because every place is the same. What we're seeing with this is not every place is the same. That's a good thing. Lots of places to explore, and they will be different if we ever manage to get there.
Yeah, I think of these as...
Do you hear me? All right, folks. So in any event, I can see from the chat, boy, you'd have to be dead to not see the reactions that we're getting. And really, when it comes down to it, media questions, they're not going to ask anything controversial. They're just not going to. They're going to hurt their reputations. They have to be on good standing with NASA and challenging them, saying anything that is going to be... is that they're just something that they're not going to want to hear, is something that these journalists are not going to do. The whole thing that, did you ever consider it? I can't imagine that you did, because why would you do something so silly? Again, they didn't even mention some of the most significant and bizarre anomalies associated with the object. Explain how a natural comet somehow sublimates material that can spear out against the solar wind to a distance of 1 million kilometers. We haven't seen anything like that. And again, the images that I saw, once again, we're looking at an object that doesn't have a tail. And we don't know where the sun, well, actually we saw some of these images showed where the sun was relative to the object. And again, we're seeing what appears to be a coma growing out towards the sun rather than away from the sun, which is again contrary to what it should be doing. So we actually saw we saw a few things. We saw a few things that were different. But in any event, I don't want to continue with this, with the media questions. We're just not going to get anything particularly interesting out of this that we haven't gotten already. So that being the case, guys, and we've run into some broadcasting problems tonight. I really apologize for that. I'm just going to have to upgrade my laptop again. Thank you, Big Daddy. Man, I appreciate your support. Thank you, Rochepi, for the tenor. Really, really appreciate it. So once again, expect to see a video from me about what these images really say. Go ahead, producer. What was that, producer? Yes, let's go ahead and do it. Guys, we're going to go ahead and pick out our random winner of the 3i Atlas shirt for tonight. Drum roll. What's that again? Papa Dutch. Papa Dutch. You are our winner tonight. Congratulations. You win our 3i Atlas t-shirt. My email is in the description. So please send me your mailing information. If you are in Europe or if you're in the United States, I should be able to mail this to you, no problem. If you're in a more remote location, may have to talk about shipping, but otherwise I should be able to cover it. So make sure I get your address information. Congratulations again on winning Sorry again for cutting them off, but man, I saw it very clearly in the comments. You guys were not happy about what you were seeing, and neither was I. We were just going to hear over and over again some very boring stuff. But Avi Loeb will come out with his own information about this. We'll learn a little bit more about what the images are really showing us, see if we learn anything new. And of course, I will bring you all of the new information that we can gather from these images. Man, what a huge crowd we've had here tonight. What a generous crowd. Thank you so much. Please don't forget to like and subscribe. And until next time, stay angry about space. Damn it.